Okay, now we're gonna learn about a new concept, which is the method of sections. In the method of sections, what we do is that when we have a structure with multiple elements, we cut a section, in this case is section N, so that we can find the forces internally. So the first step is to find external forces. All right. And in that case, we do what we have done all this time, which is the forces at the exterior of the element of the structure, or basically the support forces. So this one is a roller, so only EY, there's no EX, but this one is fixed, so we have GX and GY. And of course, they're given as P1, P2, P3. So from that, we can find Gx. There's no forces in x, so summation of forces in x equals 0. We know that Gx equals 0. There's basically no force in x, unless something else happens, like a earthquake or something. All right, summation of forces in y equals 0. We have Gy plus EY minus P1 minus P2 minus P3 equals to 0. And we have summation of moment, let's say G, so we cancel that force right there, is equal to 0. And let's say this is L, L, and this is H. So we have positive moment is clockwise, anti-clockwise. So EY times L minus P3 times L minus P2 times 2L minus P1 times 3L equals to 0. Okay, so from there we can find EY, and from EY we can find GY. So having the external forces, we can go into the components and say we're wanting to find the forces across if B, the force from B to D and the force from C to E, or any other element in here. So we cut the section, which we can only cut up to 3 elements. So that's the restriction right here. We can only cut 3 elements. And for that, we can then do a summation of forces for the element A, B, C. Summation of forces in X. Actually, let's do this. Summation of forces in X for element A, B, C is equal to 0. And then we have F, C, E plus F from B to D is equal to 0. Summation of forces in Y for A, B, C equals to 0. And then we have negative P1, negative P2, and we don't have any components in BE because remember this is like a rope. We treat it like a rope. There's only an actual force. We don't have to do components on this guy because we're doing a section, right? Okay, so that won't take us anywhere. So what we can do instead is let's do summation of moments at E. And that's why we cut the section away from E, because we can use this length as our distance. And of course, this is H. All right, so summation of moment around E is equal to 0. Counterclockwise is positive. And then we have P1 times 2L, because this is also L, plus P2 times L right, which one is next? FCE is on the axis, FB2E is going to the point, so it's not being considered, but we have a clockwise force, which is FB2D times H equals to 0. So from there, notice that we can compute, we have P1, P2, we can compute FB2D is equal to something. And from there, we can go and compute FC2E. The only one that we need to consider now is FB2E. And in that case, FB2E is pretty simple because then we can go back to what we know before, where we have the element of the triangle from B to D and from B to E. So we have this distance, which is L, and this distance, which is H, and we just found the value from B to E, from B to D, this force. So we can do what we've done before, which is either find, basically what we're trying to find here is this force B to E. So either we find the angle, or we do a ratio of triangles where we have either whichever method you prefer. So we have L2H is to this little triangle is to big triangle FB2D as F, this whole thing, FB2E is to this distance hypotenuse. And D, of course, we know D is square root of L squared plus H squared. So whichever method you prefer, you can find the angle, or you can find this hypotenuse, which is this distance from B to E in inches or meters or whatever. We have the distance H was given to us, the distance L is given, and then we simply have to do a ratio of forces. And how you do that, remember that you do the ratio between force D to E over L is the same as the ratio of FB to E over D. This is the simplest way. If you want to do cosine and find the angle, then you can do that too. And then you find your force with the cosine inverse or with sine inverse, or whichever method you prefer. Okay, so with that, let's take look at an example. Okay, and the example is telling us that we need to determine the forces through EF and GI. So EF is this, and GI is that. And of course, the same thing we do here applies for any other member. All right, so the first step, again, is to find the forces from the external, or to find the reactions from the external forces. So summation of force in X equals to 0. We have that this is By, and this is Bx, and this is Jy, and then we do have a component in X. So Bx plus 16 kilopounds equals to 0. Then Bx is in compression because it's negative 16 kilopounds, and that is this force. Summation of forces in Y equals to 0. We have that By plus Jy minus 28 kilopounds minus 28 kilopounds is equal to 0. Okay, so we need one more equation to solve for By or Jy. Let me fix that, Jy. All right, Jy. And let's do summation of moment at B equals to 0. And we have, actually, let's have a little bit of space here. Summation of moment at B equals to 0. We have, so let's do, again, counterclockwise is positive. That's the convention that we follow. So it's negative 28 kilopounds times 8 feet. So this is 8, 16, 24 minus 28 kilopounds times 24 feet. Let's see. This is going to be clockwise minus 16 kilopounds per 10 feet. Because the perpendicular distance is this guy. And then we have J that will help us find J. And this is positive. This is going counterclockwise. Positive. J y times 8, 16, 24, 32. 32 feet is equal to 0. So with that information, we can find J because it's the only unknown on this equation. So Jy times 32 is equal to 28 times 8 plus 28 times 24 plus 16 times 10. If we input that data, we have that we're going to have 28 times 8 plus 28 times 24 plus 16 times 10. And all that is divided by 32, which gives us 33 kilopounds. So all this is divided by 32. All right, so J equals 33 kilopounds. Okay, perfect. So we can go back to Y, forces in Y, and solve for By. So summation of forces in Y equals to 0. We have that By plus 33 kilopounds minus 28 kilopounds minus 28 kilopounds equals to 0. Therefore, By is equal to 28 times 2 minus 33 kilopounds. So 28 times 2 minus 33. That gives us that By 28 times 2 negative 23. What is wrong here? 22. So J is 33 and By is 23. Yeah, we're good. So By is positive 23 kilopounds. Okay. All right, so we have jy, by, and we also found bx. Yeah. Okay, so now we can find our forces that they're asking us for, EF and GI. So let's do EF first. We can only cut 3 members, 3 elements. So we can do a cut right here. And we choose how to cut. But right here is easier because we don't have to deal with these angles and anything like that. If we did the method that we learned before, then we'll have to go join by join, and then we would have to do all these angles and dimensions, which could be a little more complicated. But here is pretty easy. So at that point, what we need is the point E. Well, we're going to consider all this structure up to that point. So let's go down here and do that. So if we do, we want to find, the first one that we're going to try to find is EF. So element EF. Okay, so for element E to F, we have the points A to C to E. And so point A, point C, point D, and BD. BD, and then this point is F. But we won't connect F because remember that we cut in here. So we have element E, A to C, and C to D, A to B, C to D, B to D, and C to D. And the forces that we have are, we have a force here of 28 kilopounds, and we have a reaction here at B. So By and Bx, and we have at D, we have the force from D to, what is the next point? D, sorry, from E to G. So actually this is not D, this is E. So force from E to G, and force from D to F, and of course the one that they're asking about, which is force E to F. All right, so since we only have one force in, well, first of all, we only care about this force, so we don't have to do a lot of work. We only have to care about the summation of forces in Y. So summation of forces in Y equals to 0 to make it keep at a static equilibrium. And in that case, we know that this is going to be By, which, sorry, J, which one do we have to do? By, what is By? Yeah, By, which is 23 kps. So that's that force, minus the boundary force, which is negative 28 kps. And then the next force that we need to consider is this vertical force. And that's the one we need to find. Force from E to F equals to 0. So force E to F is equal to 23 minus 28. And that is minus 5 kilopounds. Great. So we already found one, and they're asking for two. They're asking for EF and for GI. Okay, so interestingly, GI is also a horizontal is also a force on an element which happens to be horizontal. So E to F was vertical, G to I is horizontal. Therefore, we have to make the element, we have to make a cut in a way that we can have GI exposed so we can consider it. Okay, so that was basically what we did before. We're going to cut here, and that will give us GI exposed. So it's three elements. You can cut like that, or whoops, or you can cut like this. But you decide. So we already did a horizontal, a diagonal cut. We can do a horizontal cut, a vertical cut now. So let's cut like this. And then we need all this section, we consider this section with the force J. Okay, so now we're trying to find GI. So for element GI, we have to consider the triangle from I to K. Let's see what are the points. The other points are I to K and J, which is down here, J. Okay, perfect. So this element right here will be like so. And remember that we're cutting right here. So the forces that we have are 16, J, and the internal forces from the elements that we want to consider. So we have the boundary load that was given to us, the one that we found, which was positive 33 kilopounds. And now we have to find the forces here. So if you look carefully, we have point E and F. So point E and F, which are after the cut. And point E and F will be like right here, which means that we have the force one second, the force is G and H. I apologize, G and H. Yeah, because we're finding GI. So this is G and H. So first of all, this is the force that we need to find, GI. But there's this force FHI that we don't need to worry about because they're not asking for it. But if they were, you know how to do it. You just use the dimensions. And there's this force FHJ. Okay, so in order to find that, we can do, let's do summation of forces. So since we need to find G, I already see a problem because summation of forces in X equals to 0. We have positive 16 minus force NGI minus force HJ. And summation of forces is not going to help us find a horizontal force. So what we need to do is a summation of moments. But where do we do the moment? And this is another trick. We can do the moment on the point away from the cut. So we can do it. We can either do it in H or G. But if we do it in G, we'll cancel the force that they're asking us to find. So we're gonna have the moment at H equals to 0. In that case, it should be pretty simple because we have all the information. What are the distances again? It's going to be 8 and 10. So this distance from H to J is 8, I think. Let's confirm. 8. Yeah, and this distance is 10. Okay, so let's start by doing our momentum or moment, I mean. I keep saying momentum, or moment. So this is going to be counterclockwise positive. So the force at Jy times 8 will give us a positive moment. Then we have negative moment, we'll be pulling down negative 16 times 10. And then the one that we care about, which will give us a positive moment, which is F J to I times 10 equals to 0. So that is Jy 33 kilopounds. So this is equal to summation of moments, and H is equal to 33 kilopounds times 8 feet minus 16 kilopounds times 10 feet equals, so let's do negative, positive, and keep these under the same sign, and we'll see what we get, if positive or negative. All right, so what we need to find is a force Fg to I with the following information. Okay, let's see what we have. So we have 33, well, that was negative 33 times 8 plus 16 times 10 all right, parentheses, and all that is divided by 10. Negative 10.4. So F G to I, this force, is negative 10.4. Of course, kilopounds. So that means that is another force in compression. Okay, very well. So in that case, they asked us to find the force from G to I and the force from E to F.